No. Share your name is in chat. Let me know if you hear me. Thank you. Oops, that's not what I wanted. Again, I did it. All right. So. Section 11.3 wasn't on there. I just put it on there. This will be on the test in some form or fashion. You'll be required to find a determinant. And then describe how you use that to find a solution. So I haven't quite decided how I'm going to do that on the test. The test is going to cover from section 5.1 to 311. Did we cover all of these sections? I'm not 100% sure we did. Yeah, I don't have a slide for 5.7. Section 5.7. So I'm going to go ahead and see what 5.8 is about. Five 5.8 were application problems, word problems. And I don't do a whole lot of that in this course. I do some of it, but not to the extent 5.8 covers it. So we've covered everything that's going to be on the exam. So today and Wednesday is just going to be answering questions about the homework on these sections. So if you know you're in one of these sections, 5.1 to 5.7, and this one just got put up. Let me go into that one. Calculate the determinant. Well, that's just typing in the formula, right? All right. The determinant here is the difference of the products of the two diagonals. We have this diagonal, which is the main diagonal. So that's A times D. And then we have this diagonal, which is the diagonal going in the opposite direction. Since it's opposite, we're going to subtract that product. C times D, and that's what they want you to type in there. So basically, so we find the determinant here. What is it? Right, so we do the multiplies. Since A and D are 3, so this is going to be 3 times 3, and we're going to subtract the 8 times the -3, which gives us 9 minus a -24, which is 9 plus 24. So this is 33. The determinant here is 33. So finding this determinant, well, I gave you a couple of ways of doing it. One way is using Cramer's rule, which is the rule they want you to use. They want you to use Cramer's rule. When you go on into higher mathematics, you'll come across Cramer's rule again. So it's a helpful tool. So I always use the top row. So I'm going to use 3. And so I'm going to ignore the column and the row 3 is in. So its minor is a -3, 5, 2, and 1. And I'm going to, now I'm done with that. And so now I move on to the next number in that row, which is 4. So subtracting 4 times its minor. And its minor is ignoring the top row and the middle column. The 4 remaining numbers is its minor. And then I'm going to add the final one, which is I'm going to take a -1. So I'm subtracting by a -1 times its minor. So I ignore the top row and I ignore the last column. And so the remaining 4 numbers, it's that minor. So this is going to be, this becomes 3 times the number, a -3 times 1 minus 2 times 5 minus 4 times 1 times 1 minus 1 times 5. And I plus a negative is minus 1 times, and please notice I didn't write the 1 because we're always multiplying by 1, so why write it? 1 times 2 minus 1 times a -3. So I simplify these things, so I get a -3 minus 10, so this becomes 3 times a -7. No, a -13. This becomes 1 minus 5, which is a -4. So this is minus 4 times a -4. This is a 2 minus a -3, which is 2 plus 3. So this becomes minus 5. Okay. I'm subtracting 5. 3 times a -3 is a -39. -4 times -4 is a positive 16. And we're adding 5. No, subtracting 5. -39 and -5 make for a -44 plus 16. And so what does that give me? 28, a -28. Did I do that right? this times to 0. So we find the determinant again, and I'm going to do this one using the diagonal method. Using the diagonal method. And so I have, and I'm going to use this one up here because right over that stuff. So I'm going to write these two columns again for -1, 2, -6, and 1, -5. To show the products I'm going to find, I'm going to do 4 times -6 times 3. So I'll write that down. 4 times -6 times 3 plus the diagonals going in the direction of the main diagonal, I'm adding. So -1, and I write this down even though I know it's going to disappear. -1 times 0 times 1. Right? That was this diagonal. And then the last diagonal is plus 6 times 2 times -5. Now I'm done with the diagonals going in that direction. Now I come back and go after the diagonals going in the opposite direction. Goes in the opposite direction, we subtract those products. So I have these numbers here. I'm going to subtract those products. So that's going to be -1 times a -6 times 6 minus the next product, which are these numbers. So -5 times 0 times 4. So this one's going to disappear and this one's going to disappear because I'm multiplying by the 0 in there. But I write it down anyway, so I know I'm not forgetting anything. And then the product here, so that's going to be -3 times 2 times -1. So 4 times 3 is 12, and 12 times, because I know 12 times 6 is 72. So that's a -72, because I'm multiplying by 1 negative. That's 0. And this is 12 times a -5, which is a -60. This 6 looks like a 0, it's a 6. So this is minus a -36. And this is -0. And then this is minus a -6. 1 times 2, 3 times 2 times 1 is 6, and it's negative. So now I correct for double signs. So this is still a -72. This is a -60. This is a +36, and this is a +6. So we have a -132 plus 42, which is a -90. Now, from this step to this step, I could have skipped this middle step here. And just set, well, seeing that I'm adding a negative 60 as a minus 60 and seeing that I'm subtracting a negative 36, I could have just written it as a plus 36. And the minus and negative 6, I could have just written as plus 6 and just not written the plus and minus 0 because they're not going to affect my answer. So I'm saying this is a negative 90. Right? Oh, no mistakes. This is a rarity for me to make no mistakes like this. But I'm being very careful and I'm taking my time. I'm not rushing through. Now, what I bet they're doing do not evaluate the determinants. What do they mean? Do not evaluate the determinants. In the form of determinants. So let's see what they want. Notice this right down here. This is what they want you to put in there. 2 by 2. And if it was a 3 by 3, we'd put in a 3 by 3. Okay. So we're trying to solve for x. So the 5 and 1 replace those numbers in this. And this is going to be a 1 negative. And down here, we shall do the same. But it's going to be the determinant of the coefficients. So my top row is a 1. My bottom row is a 1 and a negative 1. So now this, we're going to do the same thing. So since I'm trying to find the y, I'm using this, I'm going to replace this 1 and negative 1 with the 5 and the 1. And the 1 and the 1 are going to remain in the x column. 1. So this is going to become 5, and this is going to become 1. And then down here, it's going to be a repeat of this matrix here. Yep. I did not finish typing this in. So, yeah. So, yeah. So the next question is, What is it? So let me go back. Yes, it does. I just scroll up. So my numerator here is 5 times -1, which is a -5, minus 1 times 1. So this is a -6. So x equals a -6 divided by 1 times -1 is -1, and 1 times 1 is 1. So this is -1, which is a -2. So we have -6 divided by -2, which is 3. So my x value is is 3. And my y value, I already know what goes in the denominator. It's a -2. And so now I have 1 times 1, which is 1, minus 1 times 5, which is 5, which is a -4. So that's a -4 divided by -2, which is a +2. So I scroll back down and I tell the silly program that x is 3. X is 3 and y is 2. Yeah, let's get that from. The only time Cramer's rule is not applicable is when the denominator, the determinant of the denominator is 0. So if you find that the determinant here for the so if this is 0, then you cannot use Cramer's rule. And so here they're not giving you that intermediate step of finding out, writing those matrices. You're just gonna use your own method to find them. And I usually find the 3 matrices and then I put the numbers into the fractions appropriately. So this is a case of what are those 3 matrices? I mean, what are those 3 determinants? Actually, you have 4 determinants because you have 3 unknowns. So you're going to find the d sub x, the d sub y, and the d sub z, as well as the d. So you can find that x is d sub x over d, and y equals d sub y over d, and z equals d sub z over d. Now, I will tell you this right now, in the test, you will be required to find a 3x3 matrix determinant. I will probably ask you to use Cramer's rule or to use matrices, more specifically, to use matrices to find the solution. Well, Cramer's rule of a system with 2 unknowns. Yes. Now, here's the deal. Let me back up. Kramer's rule, let me go back to that. No, I don't show it to you. Yeah, we'll go back to the ones we already saw. Okay. Kramer's rule with a well, we're going to have to use Kramer's rule no matter what, but using the minors here really isn't applicable with a when you have 2 by 2 matrices, because that's just the diagonals. You're subtracting the products of the diagonals. And you only have 2 diagonals. Where with a 3 by 3 matrix, you end up with a total of 6 diagonals. So you take the product of those 6 diagonals and you're adding some of them and subtracting the others. You're adding 3 of them and subtracting 3 of them. Now those additions and subtractions might change simply because of what the sign of the numbers become. So yes, if you're given so solving this system using Kramer's rule, yeah, you're going to have to use Kramer's rule, but what the thing is, how you find those 4 determinants. So we have because on the test, I'll give you a 3 by 3 matrix. Let's use this one here. 1, 1, -1 is the first row. 5, -1, 2, and then 1, 3, and -1. So I'll ask you to tell me what this determinant is. And so if you want to use minors, use minors. If you want to use the products of the diagonals, use that. And so I would write the first 2 columns again, simply because the only reason I'm doing this is so I can see more clearly what my diagonals are. Okay. So my diagonals here I have this diagonal here. That's the main diagonal. So I'm multiplying 1 time. So we're multiplying 1 times -1 times -1, which ends up being a +1. And we're going to add the next diagonal in the same direction. So that's the 1, the 2, and another 1. So I have 1 times 2 times 1, which is just going to end up being 2, plus the last diagonal in that direction, -1, 5, and 3. So -1 times 5 times 3. So I'm done with that diagonal. with that set of diagonals, now I move on to the diagonals going in the opposite direction. So now I have 1, -1, and 1. And, oh, 2 negative. So I'm going to subtract the product of 1 times -1 times -1. I'm going to end up subtracting the same thing out. So that'll be nice. And then minus the next diagonal going in that same direction, 1 times 2 times 1. I mean, 3 times 2 times 1. 3 times 2 times 1, which is 6. And then I'm going to subtract the last product of the last diagonal, -1, 5, and -1. I mean, and +1. So I have -1 times 5 times 1. And so I'm going to rewrite this as 1 times -1 times -1 is 1. And then 1 times 2 times 1 is 2. And then -1 times 5 times 3, I get 15, but it's going to be negative, so it's -15. And then 1 times -1 times negative is a +1, but I'm subtracting, so that's -1. And then that's a -6. And then here I get a -5, but I'm subtracting a -5, so that's +5. Now I go through and I look for my zeros. That's usually what I look for first, which are easy to get rid of. Here's +1 and -1, so they went to 0. There's no other zeros here. So I combine my positives, which is 2 and 5. So that gives me a 7. So I added these together. And then my negatives I'll add together. And that gives me a -21. So 7 minus 21 is a -14. So each of these becomes being divided by 14. And I bet the numerators will be multiples of 7 or multiples of 14. They put here, simplify your answers. That's a huge hint. When they do not say write your answers as integers or fractions, that means that these are going to be integer answers. All right, I think they are. So now to find d sub x, I'm going to get rid of this column, and I'm going to replace it with the 3, -1, and -1. So that means I need to replace this column with those same numbers as well. So I found d, now I'm finding d sub x. So I can find out what x is. So my first diagonal in the main direction is 3 times -1 times -1. 3 times -1 times -1. Plus 1 times 2 times 1. It's not going to, wait a minute, that's supposed to be a -1 here. So that's going to be a -1 here. Plus -1 times -1 times 3 minus, and so I have 1 times negative 1 times negative 1. 1 times negative 1 times negative 1 minus the 3 times 2 times 3. 3 times 2 times 3. That was the next diagonal. And then the last diagonal, negative 1 times negative 1 times 1 minus negative 1 times negative 1 times. And this will give me, well, that's just 3, because negative 1 times negative 1 is positive 1. So that's just 3 times 1. And this is a plus a negative 2, which is minus 2, and then plus 3. Okay. And here I get 1, but I'm subtracting, so I'm subtracting 1. 3 times 2 times 3 is 18, so that's minus 18. And negative 1 times negative 1 is 1, and 1 times 1 is 1, so I'm minus 1. All right, 3 and 3 make for 6. Negative 2 and negative 18 is a negative 20. And 1 minus 1, negative 1 minus 1 is a minus 2. So this is 6 minus 22, which is I do that right? Yeah, this should have been a negative 1 here. So that's going to change this product. No, that product. Yeah. No, I caught it there. I caught it somewhere. Didn't. Oh, simplify. Okay. So simplify means I just need a fraction. So that's going to be a negative 16. So I get a negative 16 up here, which is a negative, what is that? 8/7. So this is what I'm going to type in as my answer. Because they're not telling me to round my answers to a nearest decimal place. So I'm going to need to enter it in as a fraction. I thought wrong. When I told you, I thought they were going to be integer numbers. And for d sub y, all right, these numbers go back to the original ones, which is a 1, 5, and 1. Now the 1, negative 1, and 3 are going to be replaced with the 3, negative 1, and negative 1. So this stayed the same as 1, 5, and 1, and this one became the 3, negative 1, negative 1. So now this is for d sub y, because I'm replacing the y column, the coefficients of the y's, with the constants. And so now I do all those multiplies again. Or I can do by the minors. But anyway, we have 1 times negative 1 times negative 1. 1 times negative 1 times negative 1. And then we have plus 3 times 2 times negative 1. Wait a second. No, this one isn't supposed to be negative here. So that's just going to be a plus 6. And then plus the negative 1 times 5 times negative 1. Negative 1 times 5 times -1, which ends up being 5. And then we're going to subtract 1 times -1 times -1. 1 times -1 times negative. We keep doing that multiply all the time, don't we? Okay. And then the next diagonal, -1 times 2 times 1. That's minus a -1 times 2 times 1, which ends up, this is going to end up being +2. And then the last product is -1 times 5 times -1. Okay. So this product here is 1 plus 6 plus 5, right? 3 times 2 times 1. -1 times -1 is 1, and 1 times 5 is 5. And then -1 times -1 is 1 times 1, so we're subtracting 1. This is a -2 minus a -2 is +2. This is a +5, so it's a -5. Now I look for my zeros. I have a 1. I have a 5, and I have a -1. Those go away. I have +5 and -5. Those go away. So this just adds to 8. So this is 8/14, or 4/7. I reduce it by dividing the numerator and denominator by 2. So I'm multiplying by fraction 1/2 by 1/2. So now I'm going to change this column back to the original, which was 1, -1, and 3. And 3. Now the third column becomes the constants. So I'm replacing the -1 with a 3, and the 2 with a -1, and the -1 with a different negative. And so now we do those diagonals. Yeah, it takes a while. Yeah, mathematics can be very tedious because this type of stuff. We're doing the same thing over and over again. We're just changing the numbers we're using. And just make sure you write the numbers down correctly, and make sure you're putting them in the formula correctly. So -1 times, 1 times -1 times -1. We've been doing this an awful lot this morning. And then here's a change up, +1 times 1 times -1 times 1. And then here's a product we didn't do before. 3 times 5 times 3. 45. And then we're going to subtract 1 times -1 times 1 times 3, sorry. That's this diagonal. And then the next diagonal is going to be 3, -1, and 1. So we subtract that product, 3 times -1 times 1. And then we're going to subtract the product of the last diagonal, -1, 5, and -1. So -1 times 5 times 1. This gives me 1. This product is 1. This product is -1, so it's 1 minus 1. This product is 45, right? 3 times 3 is 9, 9 times 5 is 45. 3 times 5 is 15, 15 times 3 is 45. Either way, you get 45. Here I get a -3, I'm subtracting a -3, so that's +3. Here I get a -3 and I'm subtracting, so that's another +3. And here I'm subtracting a -5, so that's +5. These two went to 0. So 45 and 5 is 50, 50 plus 6, so that's 56. That's 4. 4 times 14 is 56. How do I know that? Well, I know if I multiply 4 by 4, I'll get a 6 in the ones place. So 4 times 14 is 16 plus 40, which is, so there's my solutions. So I'm going to go ahead and type those in. So what was the numerator? 8. So it's going to be, well, first of all, I need a negative sign outside. I need a negative sign up there, and then I can write my fraction, 8 over 7. And then the next one is 4 over 7. And then my last one's just 4. And let's see if I did anything wrong. One of my responses, one or more of my responses is the Z is correct, but my other two are incorrect. So how I found those two may have been incorrect. Now, if this happens on a test, you do something like I just did here, then that's only a point or two. So did anybody notice something I did wrong? Because I obviously did something wrong because B and C are, I mean, X and Y are the ones that are incorrect. Let's go through and see what I did wrong. So this is a -1, and this is a 2, and this is a -1. And so these get replaced with 3, -1, -1, 3, -1, -1, and that's going to be a 4, -3. And so the main diagonal is 3 times -1 times -1. That may have been the issue right there. And then it's plus 1 times 2 times -1. I don't think I did that one right. But maybe. And then plus -1 times -1 times 3. All right, I know this one was wrong. So I added a 2 when I should have subtracted a 2. So that means I would have subtracted. Well, anyway, and then we're going to subtract -1 times -1 times -1. So we have -1 times -1 times -1, which is -1 cubed, which is a -1. So that we're going to end up adding 1 here. Minus 3 times 2 times 3. 3 times 2 times 3. That's -18. Yeah. And then minus the -1 times -1. Wait, times 1. So 3 minus 2 plus 3 plus 1, because this becomes a -1, and the minus a -1 is +1, minus 18, and that's a -1. This is 0. +1 and -1 is 0. -2 and -18 is a -20. And that's a +6, the 3 and the +3. And so that gives me a -14. So it's a -1 instead of what I got. Yeah, I was thinking they were going to need to be multiples of 14, because we need to get whole numbers. I mean, integer numbers. So these go back to the originals, which was 1, 5, and 1, 1, 5, and 1. So now I'm going to replace the y coefficients with 3, -1, and -1. And now I do those diagonals again. 1 times -1 times -1. One thing I did not check when I wrote down this, and one reason I got incorrect answers here, was I did not double check the numbers I put in. I did not make sure that the signs were correct in the numbers I wrote down. So I was off by 4 because I added 2 instead of subtracting 2. So that means that I need to subtract the 2 I added in plus subtract the other 2. So that brought that down correctly. Actually, it was no, it was just a -2, right? So, well, I added in a 1 when I should have subtracted a 1 or something. Or subtracted a 1 when I should have added 1. All right, so now it's plus the next diagonal. So that's 3 times 2 times 1. And then plus the third diagonal, which is -1 times 5 times -1, which just ends up being a positive 5. And then we're going to subtract the diagonals going in the opposite direction, the product of them. So 1 times -1 times -1. Keep doing that product. And then we're going to subtract the next diagonal, the product of the next diagonal going in the same direction. So that's a -1 times 2 times 1 minus the product of the last diagonal going in that direction, -1 times 5 times 3. So this product up here gives me 1. This product gives me +6. And this product here gives me 5. So this ends up being 12 here. And this gives me 1, so it's a -1. This gives me a -2, so that's going to be a +2. And right, -1 times 2 times 1. And this gives me a -15, and minus a -15 is +15. So this gives me 17 minus 1 is 16. So that's 12 plus 16, which is 28. Which is a positive 1. So I get a -1, a positive 1, and 4. That's supposed to be a -1. And this one is supposed to be a positive 1. Oh. Okay, what did I do wrong? What did I do wrong? So this is supposed to be a 1, 5, and F. This is supposed to be 3, -1, and -1. -1, 2, and -1. 1 times -1 times -1, which is a positive. 3 times 2 times 1 is 6. -1 times 5 times -1 is a positive 5. 1 times -1 times -1 is a positive 1, and we're subtracting a positive 1. -1 times 2 times 1 is a -2, and we're subtracting a -2, so it's +2. -1 times 5 times 3 is -15, and we're subtracting a -15. That's 12, 14, and 15. 14 and 15 is 29. And 29 minus 1 is 29. Oh, because that's a 2, not a 1. See, Dodo had. No, if it was the main determinant, then Z would be incorrect as well. Now it's just I find the action of that. So that's going to be a 3, a -1, and a -1, 1, -1, and 3, -1, 2, and -1. So 3 times -1 times -1 is 3 plus 1 times 2 times -1 is a -2. There was my mistake, I think. And then 1 times -1 times -1 times 3 is 3. -1 times -1 times -1 is -1, so that's minus a -1, which is +1. 3 times 2 is 6, and 6 times 3 is 18, so that's +18, or it's going to be -18. And then 1 times -1 times 1 is a +1, so that's -1. So I have a -21, and I have 3 and 3 and 1 is 7. So that's a -14. Well, I'm going to go ahead and do the final check here. And that's how we where was my D a -14? And I wrote it down as a +14? Is that what I did? Yeah, it did say Z was correct. I answered 4. And it didn't tell me that was incorrect. Let's take a hammer and beat the internet. Yeah, I just got all the signs wrong because I said D was +14. Well, let me see here. Okay, so I have one. Now I gotta hit this nail 1 times. So we have 1, 1, -1, 5, -1, 2, 1, 3, -1. So we have 1 times -1 times -1, which is 1, plus 1 times 2 times 1, which is 2, plus 1 times 5 times 3, so that becomes a -15, minus 1 times -1 times, so that's -1, minus 3 times 2 times 1, which is 6, minus -1 times 5 times 1, which ends up being +5. And so this right here is a -22. And so 3 and 5 is 8. So that does in fact equal -14. So that means I dropped my negative sign on 14. Okay. So this is why I don't like doing these as an exam question. I want you to find a determinant of a 3x3 matrix. And I'll ask you to solve a system of 2 variables, 2 equations of 2 variables. Yeah. I'm wondering what they would have said if I had typed in -4 for Z. That's curious. Okay. So solve the system using Cramer's rule. Okay, this sucks. I wouldn't do that to you online. So you find the determinant. X, Y. Yeah, right. Okay. So problems 15 and 17 are probably good. So do the homeworks because chapter 5 and section 11. Section 11 is about finding determinants and solving systems of equations using Cramer's rule. So chapter 5, I will probably, please be aware of composite functions, how you write composite functions. I think that's what that section is about. So you have 4 parts here. So they want you to find F composed with G, G composed with F, F composed with F, and G composed with G. Now, how they just want a single number answer. So we start by putting 4 into the G function. So 8 times 4 squared plus 9. That's 2 times 64, 128. So that's going to be 128. So that's going to be 137. And 6 times 137 is what you're going to put here. Doing G composed with F, you're going to do F of 2. And then you're going to square 12, multiply it by 8, and add 9. I'm going to put 1 in for X. So X1 squared is 1. 1 times 8 is 8. 8 plus 9 is 17. So I'm going to square 7, and then I'm going to put it back in. No, I'm sorry. We're dealing with F. So I'm going to put 1 in for X. So I have 1 times 1, which 6 times 1, 6. So I'm going to put it back into this function again and get 36. So this one is 36. Putting 0 in for X, I get 9, right? Because 0 squared is 0, 0 times 8 is 8, and 0 plus 9 is 0. So that's doing this G. Now I'm going to do G on what I just got. So now I'm going to put 9 in for X. So 9 squared is 81. 8 times 81 is 648. And I add 9 to that, which gives me 657. So that's how you do those. So write the compositions. This is more the type of problem you'll see on the test. I'll give you 2 functions, and I will ask for at least these 2. I don't know if I'll ask for these. But F composed with G is F of G of X, which is F of X squared, which is 2 times X squared plus 7. Right? I'm going to replace X with X squared. And that is this one. But when I do G composed with F of X, I start with the F function, and I'm going to put that into the G function. So that's 2X plus 7. What am I doing with the G function? Well, I'm squaring its argument. Here's its argument. So I'm going to square that. 2X plus 7 squared, which means 2X plus 7 times 2X plus 7, which means I'm going to get a middle term. It's just not 2X plus 7. 2X being squared plus 7 being squared. It's not 4X plus 49. I'm going to get a middle term. So we get 4X squared plus 28X plus 49. How did I get 28? Well, 7 times 2X, 14X, 2X times 7, 14X, combine them, 28X. Boom. Or 7 times 2X being doubled. F composed with F, I'm just going to put 2x plus 7 in place of x and get 2 times 2x plus 7 plus 7. I do the distributive property, which gives me 4x plus 14 plus 7, which gives me 4x plus 21. And G composed with G, I'm going to square x squared and get x to the 4th power. I did these kind of fast, but any questions? I kind of went through these kind of fast. In the previous problem, I didn't write anything down. But if you have any issues with those, please do not hesitate to ask. I'm available. The STEM lab is available. The math lab is available. We've got excellent tutors. As a matter of fact, the other day when I was getting my wristband, somebody was walking up and called me by name, and I looked at him. He looked kind of familiar. And I had him as a student at SAC for 2 classes. He took college algebra and pre-calculus with me. And he said that he got hired on here as an embedded tutor. And he's requesting to be my embedded tutor in the one class I'm teaching next semester that has an embedded tutor. So I know the quality of people that they hire for math tutors. I know their stuff. He was an A student. He did quite well. Or I think he made a B in one class and then an A in the other class. I don't remember. But it was a long, at least 5 years ago. Okay. So focus your attention on these last 9 homework sections, and come ask questions on Wednesday. Okay? Okay. If you have any questions for me now, I'll be quite happy to answer them or deal with it. If you got a specific problem from the homework you want me to look at, I'll do that. You just basically want to pull up a homework problem at random and ask and go over it. I'll do that. I was looking at my class schedule for next semester. I have one section of one. I've got 6 classes next semester. And all but one of them will be fully face-to-face. I'll have 2 sections of free calculus. And one of those has most of y'all in it. If not, all of y'all. And compare the rosters, I just noticed names I knew. Oh, yeah. Is it free count? No, it's not free count. It's elementary statistics. I'm sorry. Yeah, it's got most of y'all in. Yeah, I love teaching facts. So, y'all don't have any questions for me, or want me to work through some problems, y'all are free to go. MyLabs are used to help your exam grades. The MyLabs are to help you learn the material so you'll do well on the exams. No. If you're making above an 80 and you're doing your homeworks, then it's doing its job. There are very few people who make above an 80 without doing the homeworks. The homeworks really help your grade a lot. By doing them, because that's where you get your practice in. That's where you learn it. Yeah, but your midterm grade has no effect on your final grade. Yeah. And we're required to post a midterm grade because the state wants us to. I would not have even posted a midterm grade if I wasn't required to. Because from my point of view, it's meaningless. I mean, other than, all it means is you're doing okay, or you need to do better. So, yeah. Oh, yeah. That's one of the things I meant to be working on this weekend. Last Thursday, I went home sick, and I was pretty miserable this weekend, so I didn't do any work this weekend. I didn't do any of my chores at home either. So. Something I shouldn't have. Ravaged my digestive system more than you want. Yes. All right, go take care, and I'll see you when. Please get in there. So you can come in and ask questions or ask me to work problems or that sort of stuff.